Let's take a look at this next example. We want to set up the area using the limit of the sum. Here, we do not need to try to estimate this. We just want to set the problem up. And in order to do that, we don't even really need to know what it looks like. Is it a continuous function on this interval from 4 to 7? Yeah, there's no problems here because this function is defined for all real numbers greater than -1/2, so everything's fine over here. It's also continuous for numbers greater than -1/2. So first thing we need to know what our delta x is. Our delta x, we're taking the number from 4 to 7 and cutting it up into n pieces. That is, our width of the interval is 3 cut up into n pieces. So we have 3 divided by n for our delta x. Next, we need our x sub I for our right-hand endpoints. Pretty much, we will always use right-hand endpoints. We could show that right-hand endpoints or left-hand endpoints or midpoints all end up with the same limits, but we're not going to do that. So to get right-hand endpoints, we start at 4 plus our delta x times I. So that's our x sub I. That's where we are along the x-axis. But what we really want is the heights. We want f of x sub I. So this is going to be f of x sub I. 4 plus 3 over n times I raised to the second plus the square root of 1 plus 2 times 4 plus 3 over n times I under the root. So that is our y value. In order to find the area is the limit as n approaches infinity of the sum from 1 to n of the height. The height is this stuff, the f of x sub I, times the base. The base was 3 over n. Okay, don't forget, it's just base times height. We're finding the base. We're finding the height. And then we're just adding up base times height.